Alright, show you how to do some boring here. This is my quick way boring bar. It's a model FN, I think is what's under that tag. Something like that. Something. Dad liked putting stuff on his graffiti art. So that's a flathead V8 motor, so that's how old this thing is. So anyway, I just got done doing this 80-inch shovel cylinder here. So it's filled in with a bottle jack down here. And the boring bar goes through it and cuts a clean hole. So let me show you that's all done. Over here is the second cylinder getting ready to go. So this is a slightly worn out standard, not too bad. We'll go ahead and put some Y-scope pistons in here. These are high compression ones. So these are 10 over. And they go in at 3 thou clearance, right there. So first thing I do is clean up your cylinder surface areas. So I filed this one already. This way I have to scrape the paint and crap off. After you paint it, you take your file, that you know which way is flat on it. And always run across the surfaces just in case there's any burrs. So you'll hear it, feel it, catch it, whatever, and knock it down. So that one's good. And just wipe it off your hand to make sure there's no burrs or anything on there. Or not burrs, but grit. And we're ready to go. So over here is the boring bar. So let me go ahead and undo the bottle jack. Hey, tighten that up. There. Drop that down. You can pull the cylinder up. Good job doing one hand as usual. Yeah, one hand and one finger. How's that? So your little chips there you get rid of. It falls out. Alright, let me put this camera over here so I can do work with two hands for once. Not much for tripods, but oh well. It's hard to do this work by hand with only one hand. So there's the two cylinders. First thing I do is get rid of the torque plate that was on there. So I use a torque plate as a spacer to make it flat, because it takes this skinny surface right here, the base gasket, and turns it into a big fat surface. I don't use it for what you're supposed to use it for. Gotta clean the chips off of it, very important. Make sure there's no grit on that. And you put on your cylinder you just got done cleaning over here. Clean it one more time just to make sure. Lay it on, give it a spin, and you make sure it's flat. If it wasn't flat, you'd be able to hear a little bit of unevenness in it. So that one's good to go. So this one here is what it looks like after you bore it. So you can see what that is. Now at this point you got a little bit of a sharp edge on everything, so you want to deburr it. So you take your deburring tool. It's the one for cast iron. Tools are falling apart. So cast iron has a 90-degree cutting edge to it like that. The steel ones are more for like the ones that make a chip, which is steel aluminum. Anything that pulls a chip, that has got more of a cutting edge to it. More like a knife angle. So let's just put it around and clean the edge off. On this side too, so the rings will go in. Deburr your little corner right here. Like that. So now you got a little bit of a deburred edge there. So it keeps from cutting you, cuts back on detonation, and on this side it makes the rings go in easier. This one's ready to go in the hole. Alright, it's out of the way. Now at this point here we need to take the cylinder here and put it in the boring bar. So that's over here. Limited space here. And that's as good a picture we're going to get. Everything's in the way of doing this how I want it to be shown. Anyway, you got to make sure you got a clean surface to work to, so you got to clean all the crap off. Make sure there's no grit. If you get grit under here, it's going to cause a problem. Now the surface you come off is this top surface. That's why you get the plate on there. So stick that in there. Bring the jack up. Center the hole a little bit. Put a little pressure on it. Make sure it's sitting flat. And I always give it a little bit of a pull like this to make sure it doesn't move. Obviously you can move it, you got problems. So that would be a big problem. So here's what it looks like here now installed. So like I said, you look up in here between your surface here and up in here, make sure there's no gap. And you do it all the way around the whole thing. You also got to make sure there's room under here for the boring bar to come all the way down without hitting your spacer blocks here or running into the table, which would be bad. This here is your boring bar here. This goes down, you got a bit right here that goes in here, like this. You have a setting micrometer here that goes in this hole right here. You push it in and it has a certain depth stop. This comes out, you hit against it, and that's how you set your bit. So you want to make sure you clean all your holes out here. You get chips in there from the cutting. So yeah, that's how it does. Wipe off your tip. So that's ready to be set. Actually, it's not ready to be set. We have to center it in the boring bar first. So the way you have to center the boring bar is you got to crank this thing down. Run it on down in the hole here. You take this wrench over here and loosen up the clamp. This has a
Okay, the guy didn't say.
Okay, we're back setting the boring bar here again. Got interrupted there. So anyway, right now we're going to go ahead and center this up. So I loosened up the lock over here. So now the boring bar will move on the table. It has a T-slot net up under there in the back side up in there. So it holds it down. So all you do is just go ahead and crank it down with the handle right here. And don't run it in there like I just did. Just slide it back where it belongs. Down there. I always put my boring bar over here. Centers up a little bit more even. You want to go down about halfway down to 3/4 of the way down. That way you're getting more of an average of what a cylinder is. So if you're right here, the average of the air in the cylinder and the boring bar will be there. If you go way down the bottom here, it'll be more accurate here on centering it up. And in the air you would have to be at the top. It's like every piece of machinery has some errors in it. So right now we got clearance in this right now, those fingers down there. So you turn this knob up here, and that expands the fingers out down there, which you can't really see, but see how it doesn't move as far. So now this is tight right here. You can see this doesn't move down there now, but if you look at the boring bar, it doesn't really move. Okay, after you do that, then you go ahead and torque this down on this side over here. You want to put a little torque on it, but not super tight. And once that's there, you can go back up here and undo this. A couple turns. And then you can turn on, use power feed to bring it up, or you can crank it up by hand. And use the power feed. There. And go on out of the hole. So you got a lever here that brings it up, and you also got to hit this button up here. All kinds of little things you got to do. Alright, so once you get that up, now we can go ahead and put the bit in it. Shove the fingers in right here. Make sure they're all the way in. That way they don't catch on the edge of the cylinder. So here's your cutting bit goes in. Okay, this here I already know where it's kind of set at, so I always do an initial cut, or just a light cut to make sure I'm halfway centered. So basically this is going to be about a 2 thou cut at most, if it was a good cylinder. Okay, now you want to make sure you hold your cutting bit in like that so you don't bang your mic into it. So let me hold out my finger. Okay, it pops in. And you bring them Let the bit come out, it's under spring tension. You've got the little lock screw right here, you lock it down with your Allen. Not that much torque. And you pull that out. So this is now set for a standard bore application. Run this thing on down here. Can't really see it, but it's in there. Make sure it doesn't hit anything. Rotate it around. That way it doesn't go clunk and hit something. You got a 2-speed shift lever over here you hit. So, turn that on. Yep, low gear, high gear. Bring it up to high. And this is the power feed, drop that, and it'll start feeding. Here out the line cut. That's what we're going to here. We're going to bring this back out. Just to make sure it was on the light cut. See the cut it just did over there? See how it cuts all the way around pretty much? So that's what you're looking for, is a nice light cut. So that's only about a 2 thou cut. It's pretty well centered because it's doing a pretty good ring all the way around. That's what you want to see. So now we can go ahead and set this mic here for real. So the way we got to do that is we got to come over here. We're going to measure our piston here. Add in our 3 thou clearance, set our mic here, and then go back and set our bit. So you take your micrometer here, get out of the way. You measure across your 2 major thrust faces, so these are your thrust faces here. We can call them thrust faces because when they're in a motor, they will push against the front and the back depending if it's on load or coast. Under load it's on the back, under coast it's this way. So deceleration's on this side, acceleration's on this side. That's just how the connecting rods and stuff push on the cylinder. This here has a gap on this side for expansion. As this heats up, it grows round, it gets tighter here. So anyway, that's how pistons work, if you didn't know. So now you take your piston here, we take our mic here, stick it in here. I gotta support this a little bit with my leg. Up here toward the top is where the tight spot will be. So you move it around till you get to where you need to be. It's about 5.5 there. Come up a little bit higher. And see you're about 5.5 right there in the dial. This is really hard to do with one hand because I can't center it up correctly, but anyway, it's 5 3/4 what it's going to be set at. Hard to duplicate with what I'm doing by hand. So anyway, I'm measuring it right here up against the surface right here. So anyway, that's how you do that. Okay, so we take our number, which here was 5 3/4 is what it was set at. And then you go give it 3 thou. So you go 1, 2, 3. Back it up a little bit. Come back to the center point again. Right there. Then you take your inside mic, which are never the same as what the outside mics are. This one here is about 9 3/4 equals, where's the dial at? Right there, equals 8 3/4. And that's about where the mic is set at right here. Once again, it's hard to do on the table here, it's only one hand. You do it where you just go over the center, you can just kind of feel it. You can't see that, but it's going over center, I can just barely catch the high spot. So I can feel it. So I know this mic is set at the number it's at. Okay, this mic over here gives it a whole other setting. It's got to kind of guess what it does. So you want to leave about 3.5 to 4 thou minimum clearance. So you set this dial right here. Let me turn that light off. And I'm going to be able to focus a little better. Okay, so there's 0. You got a pinch screw here. You want to move it over. We want to leave about 4.5 or so. Yep. This one I just did the other one. It came about 1 thou. I cut 1 thou more than I wanted to. I had it at 6. So this one we're going to cut at 5. So now it's on just under 5. You come over here to the boring bar. And we do the same thing we did before. We set this. Do this with my one finger again. Oh, it's already got a screws already holding it there away, so okay, after you put it in there, you rotate it, make sure there's no drag on it. You undo the set screw. This will spring out against the mic. Of course, the damn light popped off just as it did it. Stupid light. So anyway, like I said, it's under spring-loaded tension. See how it springs into it. Okay, once you're there, you set the set screw. Lock it down, pull that out. So now it's set for 5 thousandths here, which is 1/7 over standard bore. Come down here, to there. Make sure it's not going to hit anything. Turn it on. Do a cut. There it goes. You can hear out the fairly light cut because we're only cutting a few valves. So that's feeding down the handle there. We're dropping this whole head down. This whole boring bar here comes out the other end down here. Keep the boring cylinder, it's that long. So that's how it goes. We'll come back after it's done. Okay, I got the cylinder out of the boring bar cleaned up a little bit. So we got the mic set in the hole right now. So you can see it's at, was it 5 3/4? Yeah, 5 3/4 on the, you measure it. So we're going to go up to 9 1/4 is what I'm going to finish these at. So that means I got 3 1/2 thou to hone out, which is right where I want to be. So there's what the bore looks like on the inside on this one. Cleaned all the way around, which is what you want to see. No bad spots. Alright, so this here is ready to hone. Go over to our sun hone over here. Here's our hone. These are all the different stones we use back in here. Here's some other ones for other things, and these are all the different mandrels for doing different things. So yeah, we're going to put the cylinder hones in there, which are the ones buried up in here. I'll be using ones in the county cans there. So there's our mic we use to measure it with. When we're all done, it looks like these cylinders out over here, which we just did earlier. So these are the cylinders that customer dropped the valve, so we bored these 30 over and it cleaned up all the burrs and stuff that were in there. You can see I run a relatively fine finish. See how it reflects the bench real good, see how it reflects the parts over there. I run a fairly fine finish, as you can tell. So you can see there's a piston in the background, see the piston there? It's like a photograph. So on an iron cylinder you can run a nice fine bore in there. You can still see the cross hatch pattern. I use a relatively flat one now, it seems to work better with the ring seal, but they're plateaued hone also, so they're really smooth as well as being fine grit. So we're going to be using the SS piston here and there. So here's what they look like. So we'll go ahead and hone these out over here. And actually right now they cut out with this rough ass bore mark. You see the bore finish in there. That's why you have to hone them, because they're not round. And you can see how rough the finish is in there. So we need something smoother for the rings to seal against. So these are the other cylinders I got to do. These are just stock 80s, standard bore ones. So got a couple to do here. Alright, so we'll come back later, I guess.